Alright guys, it's Scott Nielsen here, and I got 2.5F number 56. And it's on page 126, and once again, number 56. Alright, so the question is, use the intermediate value theorem to show that there is a root of the given equation in the specified interval. So our equation we got is sine x equals x squared minus x, and our interval is between 1 and 2. Alright, so right off the bat, let's see what we got to use. We got to use IVT, show that there is a root. So x equals 0, and then our interval is between 1 and 2. Alright, so in order to answer this question, we've got to know what IVT is. So IVT is basically saying that if the function is continuous, so continuous, so there's no jumps, there's no discontinuities, there's no asymptotes, no vertical asymptotes. So an example just for this question, so something like this we're looking for. So continuous, that means that there's no discontinuities, and so it'll probably cross the x-axis like that. Just for example, it could cross many times, but just for here. So what we're looking for is where it crosses in between these 2 points. We want it to cross the x-axis. So in order for IVT to be useful and be used at all, it has to be continuous. So first off, we've got to see if it's continuous, this function. So how do we do that? So we set one side equal to 0, so 0 equals sine x minus x squared plus x. Alright, so now we're going to let f of x equal sine x minus x squared plus x. And this function is continuous, so we can now state f of x is continuous. The interval 1, 2. Alright, once again we can tell it's continuous. Sine of x is a continuous function, x squared is continuous, and x is continuous. So it's a continuous function, and make sure you state this. Alright, it's essential for the markers and for this question to make sense 100%. We got to make sure this is well known, it's continuous. Alright, so for this question in particular, we're going to find there's a root. So where it crosses x-axis. Perfect example is we need a positive and a negative. Alright? And that way, so from negative to positive, or positive to negative, it would have to cross at least once. So negative positive would have to cross at least once. That's what we're looking for, a root. Alright, so we got 1 and 2, so we're going to sub in f at 1 and f at 2. Alright, so we're going to start off with f at 1. Okay, so just sub in a 1 wherever there's an x. So sine at 1 minus 1 squared plus 1. That'll just equal sine 1. They cancel each other out. 1 squared, and then a negative to it, so it'll be negative 1 plus 1, 0. Okay. Alright, so sine of 1. Alright, I wish we had a calculator here, but we're going to have to do it the old-fashioned way. We're going to have to draw a nice graph. Alright, so we're just going to draw a nice sine graph. Just draw up to pi. So pi, that's about pi over 2. Alright, so what can we tell from this graph? We know that pi equals roughly 3.14. Therefore, pi over 2 equals roughly 1.57. Alright, so where's 1 on this? Well, all we need to know from this graph we can tell is that 1, alright, sorry about that, 0, 1, negative 1. That 1's about here, but what's important, that 1 is a positive number, and it's between 1 and 0. So it's positive, we got our positive number, so we can say now that f at 1 is greater than 0. You can even draw a little arrow. It's positive. Alright, so we got our positive. Now we're looking for a negative. So we got f of 2. See if we get a negative there. If we do not get a negative, we'll have to continue to find numbers in between. Try to find a negative. But hopefully this turns out well. Fingers crossed. So sub in a 2 for every place where there's an x. So it'll be negative 2 squared plus, oops, sorry about that, minus, oh, it is plus, sorry, plus 2. Yeah. Okay, so basically 2 squared is 4 is negative 4 plus 2 is negative 2, so we're going to get sine 2 minus 2. Alright, so once again, we're going to have to use the good old-fashioned graph right here. So 2 is about here, but the main point is, especially for this, that it's positive. Sine 2 is positive, but it's less than 1 and bigger than 0. So, and if we subtract a number, so it's bigger, which is 2, so it'd be like 0.8. We can just say it's 0.8. It's roughly 0.8, so we'll say sine of 2 is roughly 0.8. Just arbitrary, doesn't really matter. All we know, the key point is between 0 and 1, and negative 2 is bigger, so I mean smaller. So 0.8 minus 2, we're going to get negative 1.2. But the main point is we got a negative number, so we can now write f of 2 is less than 0. Little arrow, negative. Alright, so what does this mean? So once again, go to the good old-fashioned graphs. We got 1 here, 2 here. So 1's greater than 0, so we can just say that it's right around here. F of 2 is less than 0, so we can say it's right around here. And remember earlier we said it's continuous, so we found that there must be a root, because in between this value and this value, it crosses the x-axis because it's continuous. Alright, so the key part to this question is it's continuous, but then the second key part is you have to have a concluding statement. Okay, so we can say, thus, by IVT, there is a root in the interval 1 to 2 on f of x equals sine x minus x squared plus x. Alright, so question's complete. There you go, guys.